to the iMDrive test simulation. I will be demoing the Team C UROV control system using my ROV craft here. As you can see here, the craft is floating. I have it at almost at the buoyancy level that I need, but the system is still being adjusted. Now, what I'll test here, I'll just briefly describe my simulation joystick. You'll see here, this is the actual X and Y axis. This is the Z and C buttons of the Wii Nunchuck, which will be interfaced through the Java application, and then through the Java application, the signals will be sent through the actual ROV, opposed to using the SCI communication. I'm just simulating using SCI, which is just basically using a Modbus version, the RTU method that I created to actually simulate with ROV. But what I'll do, I'll just show you how it dives and climbs. Now you'll see there'll be a slight movement here where it actually goes down a bit. And then I'll make it go up. You should be able to tell if it goes up. One moment. You see how it sort of jumps up? And then I'm going to show it how it goes down. Now the reason why it's not completely diving is because I'm still trying to get the buoyancy levels correct. And once I get the buoyancy at a certain point, it should be able to dive and climb as needed. Now I'll just change here. If you can see here, I'll just swap this now to 0. It should read 0 there. After I press the Z button, I'm going to press the Z button there. Now, read 0. Now this simulates driving forward and reverse. Now I'll simulate driving reverse first, because it's sort of in like a little bind here. Then I'll drive forward. Then I'll drive reverse. Okay, now what I'll do, I'll just simulate is going in an angular motion. So it goes left. And then I'll make it go right. And then I go forward. Now you can drive this in any way. Just going to back it out of there because it's in a confined space here. I'll just drive it forward. Try to drive into this little slot there. You can go in a gradual motion, so that way if you need to move at a slower rate, you can. I just go at a gradual motion here forward, so you can see and go slowly forward. This is very slow. I can go fast, or I can go in reverse. Just get my cable out here. It's sort of stopping on the cable. Reason why it's not moving entirely there. Let's put the cable in there. Now let's drive forward. Turn out of the situation. And this is that unique angular motion I was telling you about. It's pretty unique, I would say. Or if you don't specifically need to turn to the angle and then drive. You can actually drive at that angle. So I'll just drive a reverse left. Once I get an angle here, just reverse left. Try not to ram the wall there, but I'm trying to reverse left. I just forward left to show you. So that's the forward left motion. This is the reverse motion. Reverse left motion. I'm very limited in a confined space, so I can't really get the motions that I need. But I just simply demo forward, and then I show verse. This is forward, and this is reverse. Forward, reverse, left, all right. Go forward, go reverse now. Prevent from ramming. Now, from this demo, I don't know if you can see the turbidity sensor here, but it's actually sampling the light as we speak. And if I turn to the side, you can see here I'm using weights here to sort of balance everything, and I have the ROV moving in a slow motion. I'll just turn the motor there so you can see the motor actually turning. We can go forward. It's actually quite forceful, actually trying to turn, even though I'm holding it, still turning. But that's just the demo. The actual craft will be a lot more structured, and that will complete my demo here. And I will see you guys in the final.